Good morning, learners and viewers. Welcome to the session for quantitative analysis for managerial applications. Today, we will be discussing about Unit 16 and the numerical component of this paper. We will start with Unit 16, that is time series analysis. A time series is a sequence of data points measured typically at successive times, spaced at uniform time intervals. The time interval may be an hour, a week, a day, a month, a year, depending upon the purpose of the data collection. Most commonly, a time series is a sequence taken at successive, equally spaced points in time. Thus, it is a sequence of discrete time data. Examples: time series is used in pattern recognition, signal processing, weather forecasting, and earthquake prediction. Time series analysis comprises methods for analyzing time series data in order to extract meaningful statistics and other characteristics of the data. It is used to detect patterns of changes in statistical information over a regular interval of time. These patterns help us in arriving at an estimate for the future so as to cope up with the uncertainty about the future. Time series forecasting is the use of a model to forecast future events based on known past events, that is, to predict data points before they are measured. An example of time series forecasting in econometrics is predicting the opening price of the stock based on its past performance. Forecasting is an essential tool in strategic planning and decision-making process of an organization. Now we will see the various fields where application of time series is done. Economic forecasting, sales forecasting, budgetary analysis, stock market analysis, yield production related to the output, process and quality control, inventory studies, workload projections, utility studies, and Celsius analysis. Now, these are some of them, but this application is wide. The usage of time series model is twofold. First, it is to obtain an understanding on the underlying forces and structure that produced the observed data. And second is to fit a model and proceed to forecasting, monitoring, or even feedback and feed forward control. Now, what are the variations in time series? There are four types of changes or variations involved in time series analysis. These changes are called as components of time series. These are: first one is secular trend or long-term trend. Second one is cyclic fluctuation. Third one is seasonal variations. And the fourth one is irregular variations. Now we will see how they are used and utilized. We'll start with secular trend or long-term trend. In this, the value of variables tends to increase or decrease over a period of time. The variable may be population, sales, cost of living, death rates, and so on. The trend includes steady movement over a fairly long time and does not include short-term oscillations. The trend may be in the form of slow, fast increase or decrease. These changes occur as a result of general tendency of the data to increase or decrease as a result of some undefinable influences. This trend is most commonly seen in data related to economics, business, and population. Second one is cyclic fluctuation. Cyclic fluctuation, this refers to regular swings or patterns that repeats over a long period of time. Cycles are the upward and downward movements above the trend line over a period of time. The movements are considered cyclic if the fluctuation occurs after the time interval of more than 1 year, or it can be as long as 15 to 20 years. In general, these cyclics are not regular. They may have different periods and intensity. The most common example of cyclic fluctuation is business cycle. The cyclic variations are affected by erratic, irregular, and random forces which cannot be separated to measure their impact accurately. Third one is seasonal variation. Seasonal variation involves pattern of change within a year that tends to be repeated from year to year. For example, sales of ice cream increases during summer. As these variations are regular pattern, they can be predicted fairly accurately. Some factors that causes seasonal variations are season and climate. Change in climate and weather affect the sales of many products. For example, sales of coolers and ACs always more during summer months, or rather we can say that in humid. Customs and festivals. Tradition and customs also affect the pattern of sales. For example, sales of paints and furnishing goods is more during Diwali, sales of sweets is more during festivals, and many more. Fourth one is irregular variations. Irregular variations are rapid, unpredictable, and random changes in the data. The changes are caused by short-term, unanticipated, and non-recurring factors or incidents like wars, strikes, floods, famine, earthquakes, etc. The effect of Iraq war and terrorist attacks on crude oil prices is an example of irregular variations. Then decomposition of time series. The analysis of time series consists of identification of various factors which causes the variation in the time series, and the second one is separating, analyzing, and measuring the effect of these factors independently. The objectives of decomposition of time series is to break time series into four components, that is trend T, cyclic C, seasonal S, and irregular I, so as to isolate influence of each of the four components on the actual series. There are two models which are used for decomposition of time series. First one is multiplicative model and the second one is additive model. In multiplicative model, the values of time series y can be found by multiplying all these four components. So straight away we can say that y is equal to t into c into s into I. And in case of additive model, this model is based on the assumption that the effect of four components can be estimated by adding the various components of time series. That means y is equal to t plus c plus s plus I. This model is less common. It is appropriate in situations where variation in the time series are in absolute value and can be separated to each of the four parts. Here each part is independent and each part can be negative or positive. Then the measurement of secular trend. Secular trend measures the long-term direction of series. The study of secular trends helps in identification of a historical pattern. Secondly, projecting past patterns into future. And the third one is eliminating the trend components from the series. The most common method for measuring secular trend is freehand curve, semi-averages model method, moving averages method, and method of least square. Freehand, as the name suggests, the data will be plotted, and this is one of the simplest method. It consists of plotting the time series value on a graph paper and then drawing a freehand smooth curve through these points so as to reflect the long-term tendency of the data. This method is based on inspection, hence is subjective in nature. That is only a specialist with long experience who knows the behavior of the variables can draw a line by mere inspection. Second one is semi-averages method. In this method, the data is divided into two equal parts and arithmetic means are calculated for each of the parts. These are called semi-averages. These 2 points are plotted corresponding to the midpoint of the respective class interval covered by each part. The line joining these points gives the straight line trend. This line can be extended upwards and downwards to get an estimate of the future and the past values. Some of the advantages is it is not based on personal judgment, hence same trend line will be obtained every time. It is easy to understand and trend line can be extended upwards and downwards to estimate the future and the past values. Since there are some advantages, so no doubt there will be some disadvantages also for this method, as it is based on the assumption of linear trend. Use of arithmetic mean. Arithmetic mean has its own limitations and it may not be appropriate method in some cases. Then the third one is moving average method. Moving average method is based on the concept that if the observations at a point in times are averaged out with the values immediately before and after it will smooth out the irregular components of the time series. This is a very common method to determine secular trend. This method is subjective and it depends on selection of the length of period for calculating moving averages. For example, we have three methods for it: 3 year moving average, 4 years moving average, 5 years moving average. This is to remove the effect of cyclic variations. Then comes your method of least square. This is a method in which a trend line is determined using a mathematical equation of either a straight line or a parabolic curve. As this method is based on mathematical equation, it is not subjective and hence it is more accurate. The equation used for fitting a straight line is yc is equal to a plus bx, which is similar to its equation of a straight line. That is y is equal to mx plus c, where yc is the predicted value of dependent variable and x is independent variable, which is this case is time. Further, a is the intercept and b is the slope. Both a and b are constant. The trend line has the following properties. The summation of all vertical deviations are from 0. That means summation of y minus yc will be 0. And the sum of all vertical deviations squared is also 0. That is summation y minus yc is least. Now fitting a straight line. The equation for fitting a straight line is yc is equal to a plus bx, where yc is the predicted value of dependent variable. X is the independent variable, that is the time. A is the intercept and b is the slope, and both a and b are constant numbers. Now, from the data what we are having, we have to convert that data into two normal equations. And that is done to solve or to get the value of two constants a and b. So we have to convert this data into two normal equations. That is summation y is equal to na plus b summation x. And the second one is summation xy is equal to a summation x plus b summation xy. These are the standards. During later part of today's session, we will see how these equations are calculated. Auto-regressive integrated moving average, that is ARIMA, models predict future values based on past values. ARIMA makes use of lagged moving averages to smooth time series data. They are widely used in technical analysis to forecast future security crisis. An outline of Box-Jenkinson model for time series. Box and Jenkins in 1976 has proposed a sophisticated methodology for scholastic model building and forecasting using time series. A time series may be classified as a stationary in equilibrium about a constant mean, or a non-stationary when the process has no natural or stable mean. In stochastic model building, the non-stationary process is often converted to a stationary one by differencing. The two major classes of models used popularly in time series analysis are autoregressive and moving average models. Then comes what is autoregressive model? In such models, the current value of the process is expressed as a finite linear aggregate of previous values of the process and a random shock or error, that is AT. Let us denote the value of processes at equally spaced time, that is t, t minus t1, t minus 2, till and zt be zt minus 1, z2 with the deviations from the mean n, such that zt bar is equal to zt minus mean. Then we have to calculate and condition for that. That means zt will be equal to phi zt minus 1 plus phi 2 zt minus 2 plus phi p zt minus p plus at. At is the error. This is an autoregressive process of order p. This represents a regression of the variable zt on successive value of itself. Then comes the model. This model contains p plus 2 unknown parameter. That means m, phi 1 plus phi 2, and that will go to phi p. And at the last, we have sigma square p, which in practice has to be estimated from the data. The additional parameter sigma square is the variance of the random error component. Now, the second part is moving average model. This has a greater importance in the moving average model, where zt is made linearly dependent on a finite number q of previous a's, that is error terms. That means we have another equation, that is zt is equal to at minus phi 1 at minus 1 plus phi 2 at minus 2 till theta q at minus 1, which is a moving average MA process of order q. The model contains q plus 2 unknown parameters, m, theta 1, theta 2, theta q, sigma square a, which in practice has to be estimated from the data. Then comes your mixed auto-regressive model, moving average model, the third one. It is sometimes advantageous to include both auto-regressive and moving average terms in the model. This leads to a mixed auto-regressive moving average, that is ARMA, ARMM model, which is Z1 equal to phi 1, Z minus 1 plus phi p, Zt minus p plus at minus theta 1 at minus 1 minus theta q a 1 L minus p, that is number of terms. In using such models, in practice, p and q are not greater than 2. For non-stationary processes, the most general model used is an auto-regressive integrated moving average, that is ARIMA, process of order p, t, q, where d represents the degree differencing to achieve stationary in the process. The main contribution of Box and Jenkins is the development of procedure for identifying the ARMA model that best fits a set of data and for forecasting the adequacy of that model. The various stages identified by Cox and Jenkins in their interactive approach to model building are shown. Topics now. We move to the numerical part, which are the most important part of this course. There are a number of topics which includes numerical problems. So some of them are measures of central tendency, measures of variation and skewness, continuous probability distribution, sampling distribution, testing of hypothesis, correlation, regression, and chi-square test. So we will be discussing about these numericals right now. I will start with measure of central tendency. Problem is draw a frequency polygon for the given data. The data is given to you in this form. Now we have to plot a frequency polygon for this study. The first step will be converting this data into frequency distribution. So here, going back to the problem, you can see that the series starts from 500, 600, 7, 800, 900, and 1000. That means we have a difference of 100 rupees. So first, we will start with 500 to 600, 600 to 700, 700 to 800, 800 to 900, and 900 to 1000. Now, how to convert that into number of shards? You can see that for 500 to 600, we have 25. And from 600 to 75, we have 55. That means from 500 to 700, we have 55. That means from 600 to 700, it will be 30. Here it is converted in this way. Similarly, for 700 to 800, it will be 50. 800 to 900, it will be 30. And from 900 to 1000, it will be 50. Now, we have to plot a frequency polygon. For plotting up a frequency polygon, on the x-axis, we will take up the price. And on the y-axis, we will take number of shares. So since our data starts from 500, we can shift this y-axis towards 500. And from 500 at a gap of 10, we can mark 600. And similarly, in moving to 1000. And on y-axis, we can take the number of shards. That is what is called as frequency from a gap of 10. That is 0 to 10, 10 to 20, 20 to 30, 30 to 40, 40 to 50. Because you can see over here at the middle, we have highest value of 50. That means there is no need of going further on y-axis. So we will start with 500 to 600. So we will mark 25 on y-axis. And we will draw a horizontal line which will be joining the 600 part. Then we will move to 600 to 700. That is having a frequency of 30. That means we will lift this bar graph to 30. And we will draw a horizontal line which will be joining the line at 700. At 700 to 800, we have 50. So we will mark 50. We will draw a bar graph till 50, and we will draw a horizontal line when we will be joining 800 over there. And for 800 to 900, again we have 30. We will plot 30 on this, and for the last we will be drawing 15. So you can see there are 5 rectangle which have been drawn. Now, a frequency polygon is drawn by joining the midpoints of the top of these bars. We will start from the center of 500 to 600, and we will join the center of 600 to 700 bar. And from 600 to 700 center, we will join 700 to 800 center point. And similarly, we will complete this line. These are all straight lines. And we have to extend this line on the y-axis. So this line, what we can see, which have been drawn by joining the center points of the bars, is the frequency polygon. Now, we have to calculate the mean of the following group data. Here, one thing has to be kept in mind. First of all, we have to see there are different methods for calculating the mean. But by seeing the value of the frequency, if they are small, we can straight away use this formula. And if these frequencies are big, then we have to use assume mean formula. So since these frequencies are single digit numbers, so this will be converted into the table which is shown below. We'll start with interval, that is weight in kgs, 140 to 150. We have a frequency given that is denoted by F, that is 14875. And now what is the second step to convert, to start the solution? That is, we have to find the mid values. Mid values of 140 and 150. One for the mid value for 140 and 150 will be 145. Now the question is how this is calculated. So we have to add 140 and 150. We have to divide it by 2. So we get 290. 290 divided by 2 is 145. Now we have to see what is the difference. We have a difference of 10 in each. So we will be just simply adding 10 to all these values. That is 145, 155, 165, 175, and 185. Then we have to draw the fourth column, that is fx. We have to simply multiply mid values with frequency. 145 into 1 is 145, 155 into 4 is 620, 165 into 8, 1320, and similarly for 185 into 5 is 925. We will be adding all this. We will be adding summation f and summation fx. The mean formula for this is summation fx divided by summation f. That is 4235 divided by 25, which comes out to be 169.4. That means the mean for this data is 169.4. This was the simplest method for calculating the mean. Now, we have to calculate this data, the monthly salary. We have to calculate the mean monthly salary. Now, the problems looks like to be similar as what we have done earlier, but here you can see that number of firms is a 2-digit number and these numbers are too big. 12, 25, 68, 15, 10, 5. That means we will be using another method for calculating that. Now we have to find out the monthly sales. This monthly sales and number of firms, this is given to us. We have to calculate mid value, that is x. Mid value for 0 to 150 will be 75. Since the gap is of 150, so we will be adding 150 to 75. We will get 225, 375, 525, 675, and 825. That means your mid values have been calculated. Now, as a practice, we find out the central value in the mid value column. Or we can see the frequency which is maximum in the frequency column. So here it is 68. So what we will be doing, we will be using, since we are going to use assuming formula, so we will be assuming, or we can straight away put A in front of 375. Moving to the fourth column, we have to calculate D. D is x minus 375 upon 150. 375 is your A and 150 is the difference between the monthly sales. As a practice, the row in which we have placed up the assumed value, we can straight away put 0 over there in the D column. And over the 0, we can straight away There is no need for calculating it. We can write -1, -2, and below 0, it will be 1, 2, 3. Now, the last column is F into D. That means frequency multiplied by D. We are going to multiply 12 by -2, that is -24. 25 by -1, -25. 68 by 0, 0. 15 into 1 is 15. 10 into 2 is 20. And 5 into 3 is 50. So we will be summing up summation FD. And we will be summing summation frequency. Now, the formula for monthly sales, that is the mean, is equal to A plus summation FD upon summation F into I. Here, A is 375, summation FD is 1, I is 150, class difference in the class interval is 150, and summation F is 135. After calculating, we are going to get 376.11 as the monthly sales of the company. Now, the next problem is related to calculation of the median for this data. The data is given to us, the interval is given to us, and the frequency is given to us. First step is to calculate the cumulative frequency. Now the question arises how this cumulative frequency is calculated. In front of 1, frequency 1, you have to write 1, and in the second row, you have to add 1 plus 4. That comes out to be 5. Similarly, 5 plus 8 is 13. 13 plus 7 is 20. And 20 plus 5 is 25. Remember one thing. Summation of F will be the same number, the last row of the cumulative frequency, which has been marked by the M. Here 25, summation F is 25, and the last number in the cumulative frequency column is also 25. Now, summation n by 2. We have summation F as 25. 25 divided by 2 is 12.5. Now, we have to go back to the cumulative frequency column. We have to see a number nearer to 12.5. Here in this problem, it is 30. Now, we have to mark an arrow over there. In the frequency column, you have to mark this as FME. And the cumulative frequency above of this value is 5. We need these two values. The formula for your median class is 160 to 170. Going back, how to apply the formula, that is ME is equal to L plus N by 2 minus CF upon FME into I. Your L is 160, N by 2 is 12.5, cumulative frequency of the preceding class is 5, frequency of the median class is 8, and the difference of the weights is 10. Putting up all the values together in the formula, we get 169.375 as the median for this data. Now we have to calculate mode. Since this is group data, we have to apply the formula which is shown over here to calculate the mode. That is MO equal to LMO, the lowest value of the model class, plus FM minus 1 upon twice of FM minus FM minus 1 minus FM plus 1. Now we will see how all these values are calculated. First of all, we have to see where the maximum frequency is there. In the given problem, it is at 8. So straight away we will write FM. Over it, FM minus 1, and below it, FM plus 1. That means maximum number of the values have been calculated. Now the thing is that we have to calculate L and O, the lowest limit of the model class. That is 160. because our model class is the class which contains the maximum frequency. In that case, LMO is 160, FM is 8, FM minus 1 is 4, FM plus 1 is 7, and your I, the difference between the intervals is 150 minus 140, that is 10. We will straight away put all these values together in the standard formula, and we are going to get the mode as 168 after the calculation. Now, how to use the empirical relation? You know that there is an empirical relation between mean, mode, and median. We have to determine the approximate value of mode for the given data. We have mean as 5312.12 and the median is 5413.04. The empirical relation between mean, mode, and median is mean minus mode is equal to 3 times of the difference between mean minus median. On solving it, we get mode is equal to 3 median minus 2 mean. We will straight away put up the values, and we will get the mode as 5614.88. Now, we have to construct a pie chart for this data given to us. This is in response to the respondent's reply on the buying of a body perfume ATC. The reasons. This is how the analysis is done. Application is the reasons and the respondents. Reasons are seen in an advertisement, seen it on the counter, scent was good, reasonably priced, good for skin, or it can be recommended. We have the different values for the respondent. We have 280, 160, 70, 100, and when we total it up, it comes out to be 1000. Now, for converting this data into drawing up a pie chart, we have to calculate 2 more columns. Now, how this is calculated? We have column number 1 and column number 2 given in the problem. Column number 3 is the percentage of the respondent. That means the percentage of individuals in the process. That is, for first one, it is 28%. For second is 16%, 7%, 10%, 18%, 21%, and when we total it up, it comes out to be 100. And the total for number of respondents is 1000. Now, we have to convert this percentage of respondent into degree of anger. 1% is equal to 3.6 degrees. So we will be straight away multiplying this 28 by 3.6. We get 100.8 degrees, 57.6 degrees, 25.2 degrees, 36 degrees, and 64.8 and 75.6. When we are going to add up, we are going to get a complete circle of 360 degrees. Now, how to draw it? We have to draw a circle. There are 5 components in it. We have angles with us. So we can we can draw a circle with an appropriate radius, and we can start it from taking up a horizontal line, and with the help of D, we can draw different angles. That is 100 degrees, 57 degrees, 25.2 degrees, 36, 64, and the last part which will be left will be 75.6 degrees. The representation in the pie chart for different reasons have to be denoted by different colors. For blue, we have taken as seen in an advertisement. The second one is seen in the counter. Third one is seen, and it was good, reasonable price. Fifth one is good for skin. The last one was recommended. So we will color this pie chart with different colors, and the figure what we get is the pie chart. This looks like this. Now we move to second part, that is measure of variation and skewness. The following data is for the sales made by different companies in a year. Calculate the quartile deviation and its coefficient. Is this an appropriate measure for the study of measurement of variability? We have to comment on it. So this data is given to us. Now the second part is convert this data into cumulative frequency. 4 in front of 4 we will write 4, and in the second row we will add 11 to 4, that is 15, and similarly we will be performing it till the last, till we get 60. When we are going to sum up the number of companies, we will get the same number, that is 60. Now first step, we have to calculate the quartiles Q1, Q2 and Q3. First one, your n is 60. Quartile 1, that is the size of the 60 by 4 term, that is 15 item, has to be used. Now the thing is that where this 15 comes in your cumulative frequency column, it is in the second one. That means that lies in the group 40 to 45. Now we move to Q3. That is 3 times 60 by 4. That comes 45. So we will straight away go to this table and see where this 45 lies. 45 lies in 48 value. That is 55 to 60 group. Q1, Q3 we have calculated. Now, these are the formulas for calculating Q1 and Q3. Q1 is L plus N by 4 minus CF upon F into I. From this, we can take up the values. That is 40 plus 15 minus 4 by 11 into 5, which comes out to be 45. Similarly, for Q3, that will be L plus 3N by 4 minus CF upon F into I. We get 60. Quartile deviation is Q3 minus Q1 by 2, which comes out to be 7.5. And the coefficient of quartile deviation is Q3 minus Q1 upon Q3 plus Q1. Putting up the values together, we get at 0.1428. Now, for the given data, we have to compute Bolli's coefficient of skewness, Carl Pearson coefficient of skewness. Data is given to us, so we have to convert this into our application. This is, here we can see that this is a broad way of solving, because we are given only with monthly sales, monthly wages and number of employees. So we have to calculate standard deviation, mean, median, then we will apply skewness formula. First of all, we have to start with the mid values. Mid value will start with 150. Since the difference is of 100, so we will be adding 100 to all these values. We get 650, 750, 850, 950, and 1050. We have to calculate T. T is X minus A by I. As a practice, we take up the value in the center of this table. Either it can be 850 or 750. We're going to get the same answer. I have taken A is equal to 750. As I told you, in the value of T column, straight away write 0, and above it write -1, -2, and below 0 write 1, 2, 3. Calculate D square. We have to do this. Square of -2. Square of -2 is 4. Similarly, we will be doing for all. Then we have to calculate FD square. This D square column has to be multiplied by F. Then we have to calculate FD. And the last column, you have to calculate cumulative frequency. All these values have been calculated. Now we move on to the formula. First of all, we have to calculate the mean. Mean is equal to A plus summation FD square upon N into I. Picking up the values from the table what we have calculated. 750 plus 20 by 120 into 100, which comes out to be 766.68. Then we have to calculate standard deviation. Standard deviation is summation fd square upon n minus summation fd by n whole square. Don't get confused by these two values. First, in the first value, it is summation fd square. That is 190 over here. And in the second one, that is summation fd by n whole square. Summation fd is 20 by 100, and then the square has to be. And I is outside the under root. That means here I is 100. So we are going to get the value of standard deviation as 124.8. Now moving to median. Median is L plus n by 2 minus CF upon F into I. N by 2 will be 60. So here, which is that interval where you are going to get the value of 60. That is in the column having 80 as the cumulative frequency. That means your median class will be 700 to 800. L is 700, n by 2 is 60, CF is 35, I is 100, and the frequency of the median class is 45. Putting up all the values over here, get median at 755.66. Then comes your mode. Mode is LMO. This formula is known to you. We have to see the column of frequency having the maximum frequency. Maximum frequency is of 45. That means your modal class LMO will be 700. LMO is 750. I is 10. FM is 45. FM minus 1 is 25. FM plus 1 is 20. Putting up all the values, we get 744.55. Now we have calculated mean, we have calculated standard deviation, median, mode. Now we will move to the formula for trial Q1 and Q3. Q1 is L plus n by 4 minus CF upon F into I. That is 600 plus 30 minus 10 upon 25 into 100. We get 680. Similarly for Q3, we get 850. Now, what is the formula for Bowley's coefficient of skewness? That is denoted by SKP, mean minus mode upon SD. Mean is 766.68, your mode is 744.55, and your SD is standard deviation is 128.8. On solving it, we get 0.18 as the Bowley's coefficient of skewness. Now we will move to Carl Pearson coefficient of skewness. That is denoted by SKP, Q3 plus Q1 minus 2 median upon Q3 minus Q1. Putting up all the values in this relation, we get 0.11. Now you see, the first number after the decimal value is the same. So that means there is hardly any difference between the values of coefficient of skewness by different methods. Now, the most important part, the problems related to probability. A problem in statistics is given to three students, A, B, and C, whose chances of solving it independently is 1 by 2, 1 by 3, and 1 by 4 respectively. Find the probability that the problem is solved. Second one, at least two of them are able to solve the problem. And the third one is exactly two of them are able to solve the problem. Now you can see that there are three students. They have the respective probability of solving the problem. Let they be denoted by PA, PB, and PC. And the probability for not solving is denoted by PA bar, PB bar, and PC bar. Now the First part is the problem is solved if at least one of them is able to solve the problem. That means the problem is given to all the three students and solving the respective probabilities is known. Now the thing is that how to calculate that the problem is solved. That means we will subtract it from 1, the probability of non-solving the problem. The non-solving problem for PA will be 1 by 2. PB will be 1 minus 1 by 3, that will be 2 by 3. And for PC, it will be 1 minus 1 by 4, that will be 3 by 4. So after calculating, we are going to get the problem as a solution of this problem as 3 by 4. That means 75% the problem can be solved. Now, at least two of them are able to solve the problem. In this case, we have to apply union method as well as intersection method for the different probabilities or the different conditions. We have to calculate PA intersection B, union B, B intersection C, union A intersection C. Now we have to apply probability of mathematical application. B A intersection B is PA into PB. B intersection C is PB into PC, and A intersection C is PA into PC. So we will be multiplying these two and we will be adding up. Minus 2 times of PA, PB, PC. We have the different values given in the problem. We will straight away replacing these values. After calculation, we are going to get 7 by 24. Third was exactly 2 of them are able to solve the problem. That means 2 of them will be solving and the third one will not be solving. So in this case, it will be B A intersection B intersection C bar union P A intersection B naught intersection C union P A negative intersection B intersection C minus, when we will converting this into a mathematical relation form. So that will be PF into PB plus PB into PC plus PA into PC minus 3 times of PA, PB, PC. This comes out to be, after calculating it, we will get a value of 1 by 4. Now we will see another problem related to probability. The probability that a student A solves a mathematics problem is 2 by 5. And the probability that a student B solves it is 2 by 3. What is the probability that the problem is not solved? First one. Second one, the probability is solved. And the third one, both A and B are working independently of each other and solve the problem. We have 2 probabilities, PA and PB. The negative, that means PA negative will be 1 minus 2 by 5, that will be 3 by 5. And PBBR will be 1 minus 2 by 3, that is 1 by 3. Now, first of all, the problem is not solved. That means nobody is in a position to solve the problem. That means we will be doing multiplying PA bar into PB bar. PA bar is 3 by 5 and PB bar is 1 by 3. On multiplication, we are going to get 1 by 5. Second one, the problem is solved. Problem is solved. The methodology is very simple. Earlier, we have calculated the problem is not solved. If the problem is solved, subtracted by 1. 1 minus 1 by 5 is 4 by 5. That means 80% the problem will be solved. Now the thing is that both A and B are working independently on each other and they solve the problems. That means we will be multiplying their respective probability of solving the problem, that is 2 by 5 and 2 by 3. It comes out to be 4 by 15. Now, another case methods of solving the probability problem. An insurance salesman sells policies to five men, all of identical age and good health. According to the actuarial table, the probability that a man of this particular age will be alive 30 years hence is 2 by 3. What is the probability that 30 years hence at least one man will be alive? Here we have three numbers given to us. The thing is that how this information is transformed into a mathematical or probability notation methodology. Here n is 5, we are talking about 5 people. The probability is 2 by 3, which is given in the problem, and it is denoted by b, then q will be 1 minus 2 by 3, which will be 1 by 3. Now we have to calculate at least one man will be alive. That means one probability r is greater than equal to 1, which is equal to 1 minus p r equal to 0. For this case, we have to apply combination method. 1 minus 5c0, 2 by 3 raised to the power 0 into 1 by 3 raised to the power r. On calculation, we get 242 by 243. Keep one thing in mind. Probability of any event cannot be greater than 1. If you find that you're getting an answer of probability calculation greater than 1, that is a sure case that some mistake has been committed while solving the problem. The second case is at least 3 men will be active. That means we have to calculate, since there are 5 people in this, so we will straight away calculate PR is equal to 3, PR is equal to 4, and PR is equal to 5, and we will be adding the respective probabilities, which comes out to be 64 by 81. Next problem is the distribution of the total time a light bulb will burn from the moment it is first put into service is known to be exponential, with mean time between failure of the bulbs equal to 1000 hours. What is the probability that the bulb will burn more than 1000 hours? Here, your m is equal to 1 by 1000. We have to calculate the probability that the bulb will burn for more than 1000 hours. It will be represented by p, t greater than 1000, which is equal to 1 minus p, t less than 1000. So we will straight away find out the probability of 1000. And we will be subtracting that probability by 1. So we have to apply exponential method. E is equal to minus n lambda upon p. So your np is minus 1000 into 1 divided by 1000, which comes out to be e minus 1. The value of e minus 1 will be given to you in the problem. So we will be subtracting 1 minus p minus 1. We are going to get the value of as 0.368. Now we take up another problem, which is the average number of customer arrivals per minute at a super bazaar is 2. Find the probability that during one particular minute, exactly 3 customers will arrive. Second, at the most 2 customers will arrive. And the third one is at least 1 customer will arrive. So here we have m is equal to 2. We have to apply probability r is equal to 3, that is e raised to the power minus 2 into 2 raised to the power 3 upon 3 factorial, which comes out to be 0.1804. Now, for the second case, we have to calculate at most 2. For at most 2, we have to calculate probability r less than equal to 2. That means we will be adding up all the values of 0, 1, and 2. That means straight away the formula will be e raised to the power minus 2 into 2 times power r upon r factorial. Your r is 0, 1, and 2. When we will be adding all these values, we will be taking my e raised to the power minus 2 in front, and then we will be multiplying this 1. We will be adding 5. Straight away we are going to multiply 0.154 by 5. Value of e minus 2 will be given to you in the paper, or it can be taken from the tabular form. And the third one is probability r greater than equal to 1. Straight away we can calculate 1 minus p r is equal to 0. For r is 0, we will apply in this formula, which comes out to be 1 minus e raised to the power minus 2. Value of e minus 2 is known to us, so we will be multiplying it, and we get 0.8646. These are the methods by which the problems related to probability are solved. With this, we will be concluding today's session. एक सेशन और करवाओगे इसका